Hello students. Now let us understand how quicksort algorithm works. So this is the algorithm for quicksort. As we know that there are two partitions of quicksort algorithm. One section where we are calling the quicksort algorithm recursively by sending the two partitions of the array, the left partition and the right partition across that pivot element. And then once we call the partition function, then we actually find out the pivot element with respect to its LOC position. So if you look at this particular part of the code, here we are calling the quicksort algorithm by sending the actual array and its beginning index and the last index. Until the beginning index is lesser than the last index, we keep partitioning our algorithm with respect to the pivot element, across which all the values to the left of the pivot element will be lesser than that value, and all the values to the right of the element are the greater than these values. And once we get the pivot element, we again call this function recursively by sending the value, which is the array, the beginning value, and the value before the LOC. That means the left portion of the array before LOC. Similarly, the second part, which is the right uh, side of the array, that means the right of LOC. So LOC plus 1 till the end. Right? So we are basically dividing our array with respect to that LOC that we are getting as a pivot element. Now, first of all, we need to understand how we get that pivot element. So this is the procedure for that. So the pivot element is found using few indexes that we have to set initially. So here we have. So here we set three pointers. Left, that is pointing to the beginning of the array. Right, which is pointing to the end of the array. And then we have a LOC, which is our pivot element. We will always consider here, we'll assume here that the very first element of any partition of the array that we are getting is the pivot element. And we are also using one flag variable, which is initially zero. We're going to repeat this process till our flag is zero. That means once the flag turns 1, we are supposed to stop the process. Now, here there are two sections of the code. Step 3, 4 is for comparing the LOC, which is on the left side, with the values on the right side. And step number 5 and 6 is where the LOC is on the right side and we are comparing it with the left side. So the process here is that if my LOC value, which is on the left side, if it is lesser than the right value, then the order is correct. And LOC is not right, which means I have to keep decrementing the right pointers. I have to keep coming towards the LOC side. Okay. There will be a point where the LOC will decrement and it will reach to LOC. That is the flag raise condition. So we have to raise a flag that this is a stopping condition. If nothing of this is happening, that means my LOC is actually greater than the right value, which is a false condition because I want LOC to be always lesser than the right value. So if this is not so, we swap the two values, and we update our LOC as right. That means now your LOC will go to the right side because we swapped the value to the right value. Now this is what a condition where LOC was on the left and we are comparing it with the right element. Now just reverse of that, your LOC is on the right side. So we have to compare it with all the left elements. Now whenever LOC is on the right side, all the elements to the left of it should be lesser than that value. So we're comparing the same thing that if the flag is still 0, that means my flag has still not turned 1, which may be because I have not reached to this condition and somewhere has swapped and therefore my LOC has become right now. So my flag is still not 1. That means I have to see that my LOC should be now greater than the left value. Yes, because all the left values should be lesser than the right values, lesser than the LOC values. So if the LOC value is greater than the left value and your LOC is not left, so you keep decrementing left because you have to keep going ahead to check the negative values. And in that case, you are incrementing left. There will be a point where left is incremented and it reaches to LOC. So if your LOC is reaching to left, that is a stopping condition. So you have to raise a flag. So flag is 1 and you're returning that flag. But if none of this condition is there, that means if any value to the left is actually greater than the LOC, Then we are supposed to swap these two values. So we are swapping these two values. And because we are swapping it with the left value, our LOC will now update as left. So this is the process which is actually giving us that LOC value. So after this, you are supposed to return that LOC value to this function, which will then partition your array according to that LOC value, the left side and the right side. Now let us understand it with the problem, with a proper problem. So let's say this is an original array, and you see here, our problem here is to perform that partition. So as I mentioned earlier, partition is a pivot element which you have to find, for which we have to find a correct position. Initially, the beginning of the array is left pointer, the ending of an array is the right pointer, and the first element itself is our pivot element. Here we are calling it as LOC. Now, as I explained in the algorithm, the left value, that means the pivot value, the LOC value, should be always lesser than all the right values. So always, whenever your LOC is on the left side, you compare it with all the right pointer values, right? So our logic here is that LOC should be lesser than right. And if this is the case, you keep decrementing right towards the left side, right? So here, if you see, 3 is actually lesser than 7. So we decrement right. So right goes to the next position, which is 9. Again, 3 is also lesser than 9, which is a true condition. Therefore, we are decrementing right. So next is 8. 3 is lesser than 8. Again, a proper order, and therefore we have to decrement right. So again, I'm decrementing right. 3 is lesser than 10. Yes, the condition is true. So decrement right. Now I have come to a point where 3 is not lesser than the right value. Here 1 is lesser. And in this case, what you're supposed to do, we are supposed to swap these two values. That means 3 will come here and 1 will come here. And when we are swapping, with whichever pointer you have swapped, your LOC will become that. So once you swap your 3 with 1, so your 3 has come over here. Your LOC is now right. That means your LOC has come here. So you have to update your LOC position. That means now my pivot element has come here. From here, it has come over here. Now, when your LOC is pointing at the right index, you are comparing that with the left value. So now, as I mentioned, the left value should be lesser than the LOC. That means your LOC should be greater. This is the condition where you keep incrementing left value. So let's check that. Is your LOC greater than the left value? Yes, it is true. So that means this order is right. So we are supposed to increment left. So left pointer is incremented. Again, is your LOC greater than left? No. In this case, left value is greater than LOC. In this case, we have to swap these two values. So 12 will become 3, 3 will become 12. So we are swapping there. And with which pointer we are swapping LOC? With left. So your LOC will be updated as left. So here, 3 has come over here and LOC has become left, 12 has come over. Right? So this is where we have performed swapping because they were not in proper order. Now at this position, your LOC is at the left side. So it needs to be compared with the right pointer. And because it is on the left side, it should be lesser than the right values. So A of LOC is lesser than right value, you decrement right pointer. Right? So because they are in proper order, so we're going to decrement right pointer. So right pointer will come at 2. Again, LOC should be lesser than 2. Here the condition is false. That means we need to swap these two values. And after swapping, we have to update LOC. So 3 will come here, 2 will come here, and LOC will come here. So the next case, 2 has come to this side, 3 has come to this side, and because we have shifted LOC, so your LOC will become right. Now, when LOC is on the right side, we compare it with the left side. So these two are in proper order. So now we'll increment left, so left will come ahead. These two are not in proper order, so we are swapping them. So 3 will come here, 4 will go here, and LOC will update it to left. Then again, if it is on the left side, you compare it with the right pointer. So LOC will be compared with the right. 3 and 4, they look in proper order. Right side value should be greater than the left side, which is true. So right will be decremented, right will come. Again, right side should be greater than LOC, which is true. So right decrements. Now this is the condition where all your pointers have become 1. And we know this is a stopping condition. There will be a time where right decrements and it reaches to the LOC value, or left increments and it reaches to LOC value. This is a stopping condition where you raise a flag 1 and return your LOC position. So this pivot element has come to its proper position because if you see, all the left values to the left of this pivot element are lesser than that. All the values to the right of this pivot element are greater than that, which means irrespective of their sorted order, they might not be in sorted order, but all the numbers to the right are greater than 3. So this number has come to its proper position. That means when the next recursive function is called on quicksort will take this half array and quicksort will take this half array, remaining array, and perform the same operation to find its pivot elements. And it will be doing the same till all the elements have come to its proper position as pivot element. So this is what your quicksort algorithm looks like. So you just have to show the first iteration. That is how the first element, pivot element, is coming to its proper position by shifting its value to the left and right pointer. So this is quicksort algorithm. Thank you.